Okay, so yesterday we were looking at graphing cosines, and I asked you to do the 4 problems that were left on the page front and back. So we're going to check, you're going to go through it, make sure that you've got it graphed correctly. So the first thing that we need to look at is we need to look at the amplitude. And amplitude is the absolute value of that number. So the amplitude would be 2. So when it swings across a reflection line, basically midline, it will go 2 up and 2 down. Okay. Now the period. Period is 2 pi over 2. It's the number in front of the theta or the variable x. So when you do that, you get a period of pi. So a cosine wave looks like that. So what we have to understand is we know the starting point, we know the ending point. If we go halfway, we will get the, I hate to say midpoint, but we'll get the midpoint, right? We'll have a point here. Now, so the period of this is pi. Amplitude is 2. Well, I'll put a starting or ending dot there and a starting dot there. I will also come down to -2 because half of pi is pi over 2, and it's got to swing that low. Now, you can take and you can find exactly where to put these dots on the pi over 4 and 3 pi over 4. But our first 3 dots came from beginning, end, and middle. Beginning, end, and middle. So you have to have those. If you do not get those, then it's pretty bad. Now, if we were to look at this, what is the cosine of pi over 4? What's the cosine of pi over 4? Okay, square root of 2 over 2. Okay, so what we have, if you think about this, is 2 times cosine of 2 square root of 2 over 2, right? Yeah. And you can find it numerically, and that's fine. What we were looking at yesterday were the graphs. So on your yellow calculators, type in, well, I guess you could, here, we'll just do it like this because it'll evaluate it for you. Right? You should be in radian mode, but 2 cosine of 2 times pi over 4, and then do you get 0? Tell me what you get out. So when you evaluate this, you get 0. Now, let me show you something. What is 2 times pi over 4? 2 times pi over 4. That's really pi over 2, right? 2 pi over 4 is pi over 2, correct? Okay, what's the cosine of pi over 2? Zero. What's 2 times 0? Okay. Now, let's do the next one. It'd be 2 times cosine of 2. This is 3 pi over what? 4, right? And this x value 3 pi over 4? Excuse me. Yeah? Okay. What does it equal? That would be 2 times cosine of, what's 2 times 3? 6 pi over 4 is what? What's 6 pi over 4, guys? 3 pi over 2. Please tell me the cosine value of 3 pi over 2. Come on. What is it? 0. So this point ought to be what? 0. Right? So do you see how we did that? We can find excuse me, we can find the points necessary. They're in quarters. The x-axis in pi over 4, so they're in quarters. The period for this one is pi. And now all I have to do is this. Right? And it would repeat. Is there symmetry about the midpoint? Is there symmetry about the midpoint? Yes or no? Yes. There is. If you find that that comes out to be 0, guess what? This better come out to be what? That's right. Do you see how we did this? Do you see how you evaluate a cosine or a trig function? No. We plugged in the x value, 3 pi over 4, right? Right here. Our equation is 2 cosine 2 theta, right? So I multiplied 3 pi over 4 times 2. That got me 3 pi over 2, right? 6/4, which simplifies down to 3 pi over 2. Right? You look on the unit circle, what's cosine 3 pi over 2? That's right. So that's how you do it. And then it's times 2. Anything times 0 is 0. So, okay? Questions? The beginning, the middle, and the end all come from the amplitude and the period. Do you understand? So that's 3 of your dots. All you have to do is find one more because there's symmetry about the midline, right? All right, let's do another one. Need you to do this problem. I need you to graph it. I need you to find amplitude. I need you to find that. These are things that you should have already completed as of last night. So I'll give you a minute to look at it and correct your stuff and do it. Okay. Amplitude. 3. It's absolute value of 3. I keep saying absolute value of 3 because that 3 could be negative, right? So let's look at our period. That is what? 2 pi over b. Folks, what is b? Is b 3 or is b 1/3? See, because this is cosine b of theta, right? It's 1/3. So what does that give me? Six pi. So we're about to stretch a cosine with an amplitude of 3 out to 6 pi. Now, how far does your x-axis go? 4 pi. Okay? So we're going to say this is 5 pi, and we're going to say that this is what? 6 pi, right? Now, don't sweat that, because guess what? They're giving you the other side of the x-axis to graph it as well, right? Okay? So you got to make sure you understand that. They don't have to give you a full period to the right. They can give you a full period. There's 8 pi up there, is it not? I see 8 pi of distance on the x-axis. We only need 6 of them. So they actually gave you 2 that you didn't need, right? So you've got to understand that. But if you do this, life will become much easier. Watch what I'm about to do. Where do I start at? At where? Where did I start at, guys? 3. Any questions about starting right there? Anybody? Now, what's half of 6? 3 pi, right? So I know that I have to be down here at -3. Do I not? Yes or no? Any questions about that? The whole period 6, half of it is what? 3, and that should be my trough, right? Yes? Anybody confused about that? That has to be like solid. Now, watch what I'm about to do. I could come back up and go, okay, there's 6, there's my ending point, right? Guys, watch this. What did I do? I went back on the x side, negative x side, right? Negative tangent, or not negative tangent, negative radian side, right? Anybody confused about how I got this point? It'd be really nice if they had this one up here as well, but I put it there, didn't I? Can you put it there? Most definitely. Now, there's only one other point that we need. We only need to evaluate it one time, right? We need something on these quarters, correct? So, evaluate. Man, what is this called? Oh, snap, crackle, pop. But they're in thirds, right? They're not quarters, are they? Yes or no? Well, I don't have just 3 of them. I've got 2 of them that I've got in here, right? So let's see if we can evaluate this. Can you evaluate 3 cosine of pi over 3? Can you evaluate 3 cosine of 2 pi over 3? Do y'all see how I'm getting that? Here's pi, here's an x, here's my other x, which is what? 2 pi, right? That's my thetas. Yes or no? Everybody is in that. Yeah, you got the unit circle? Boom. Use the unit circle, okay? We ought to be able to do that as much as you can. So what is the cosine of pi over 3? One half. This right here is 1/2. So that's 3 times 1/2, which is, guess who? 3/2, right? Yes? Y'all, 3/2 is really what as a decimal? Huh? It is 1.5. So at pi, I should be setting at, guess what? 1.5. Guess where I should be setting over here at negative pi? 1.5. Yay or nay? Oh me, oh my. Any questions about that? No? Yeah? Okay. You evaluate 3 times cosine of 2 pi over 3. Evaluate by hand, meaning use the unit circle. Don't just type it in and get a value. You need to be able to use the unit circle and do what I've done here. Okay? You want to fully understand this, then do this. Because by doing this, you understand. You're seeing things. If you type it into the calculator, you're getting a result, and I hope you typed it in right. So give you 15 seconds to evaluate that, and then plot it. Go. Okay, what did you get? What is the cosine of 2 pi over 3? Negative 1.5? So that's 3 times negative 1/2, right? 3 times negative 1/2, which is negative 3 what? Of 2. Well, that would mean that this one is where? Right where? There? So where would this one be? Right where? Woo. So where would it be right here for 4 pi? Where would you expect 4 pi to be? Where's right there? Huh? No. Why would you expect at 4 pi it would be negative 1.5? Why? What does it have? Starts with an S, ends with a Y, got an imagery in it. What is it? Symmetry. What does symmetry mean? That if you fold it, those points should lie right on top of one another, right? Which means the same distance away from the line of symmetry on these should be the same outputs, right? Correct? Somebody real quick do 4 pi over 3. What's cosine 4 pi over 3? It's got to be 1/2, a negative 1/2, right? Yeah? Right? Now, how did I know that? No. Because it has what? Symmetry. See, if this point over here came out, the cosine of 2 pi over 3 came out to be negative 1/2, then if I'm still doing below the unit circle, right, on the bottom 3 and 4 quadrants, right, then I ought to be at negative 1/2. So there you go. 3 times negative 1, still should be that. And then what would you expect this right up here to be? At 5 pi, you would expect it to be what? 1.5, right? Do y'all understand? Do y'all see? We've got the beginning, end, middle, and then let's look at the points there in between. Because once we find it, there's symmetry about it. Yes or no? Sure. Okay, so I'm going to show you something. Do this. Okay, so since my amplitude was 3, I'll go negative 3 and positive 3, right? That okay? And then I'll just hit graph. Okay, so that's the full gamut right there, right? So what's this? This is pretty cool. So if I go, let me make sure that I've got my table set. Let's do it. Okay. I want my table set to start at 0, and then I want it to step. That means my change in my table, my x values in my table are going to change by pi. Would that be okay? And then if I look at it, Voila. Everything's there, is it not? Zeros, 3, 3 point, pi came out to be 1.5. 2 pi came out to be what? Negative 1.5. 3 pi? How about that? Do you see those numbers repeating on that? Do you see the table? What numbers am I dealing with? 3, 1.5, what? Negative 1.5 and what? Negative 3. Do y'all see that? Yes or no? I was hoping that some of that would be okay when you did the homework last night, but I'm not too sure that everybody went home and done homework last night. Because y'all know that there's a quiz tomorrow, right? And you know I'm going to be bringing it, because I'm making some real deep connections right now. How about you? Know what you know what you don't know, because Homer's going to find out what your unknowns are, right? Yeah. Okay? Huh? Okay, in the TI, what are 36X Pros, you got to make sure you're in radio mode, right? So that's an easy change, right? But I want you to see these numbers. Do y'all see this? Do you see the patterns? Do you see where we got the unit circle? We use the unit circle. Do y'all see that? That's your go-to. You've got to be there. Okay? Now let's switch gears. We've done, this makes our third cosine, right? There went before on the sheet. You need to have one to practice. Answers are up on Google Classroom if you'd like to check it. Let's go to sine. Ready? Woo, number 2. I need amplitude period, and then I need for you to graph it. I need for you to graph it. Go. So you've done enough, either the wheels are on or the wheels have fell off, right? Going to a calculator can be a really bad thing unless you know what you're doing. Because calculators will give you an answer, whether it's right or wrong. And that's what you got to understand about calculators. It's your tool. But the tool is only as good as what you put into it, right? Okay. So what's my amplitude? Absolute value of 2, right? Which is 2. What is the period? Well, that's 2 pi over, let's see, here's my B, right? Here's my B. If I quit writing B, I would be able to write 3. So, oh my gosh, I got a period of 2 pi over 3. Snap. Oh man, that was making my head hurt. Oh man, okay. I can do this. This is great. Because look, but listen, I got pi over 4, pi over 2, 3 pi over 2, and then pi, right? Man, why wouldn't they just give it to me in thirds? Wouldn't that have been a lot easier? Yes or no? No? It wouldn't have mattered? Look at my denominator. It's in what? 3. What are these in? Pile of 4s, right? Yeah, it's going to mess with you, right? So, we'll do a quick Etch-a-Sketch. What I mean by a quick Etch-a-Sketch? Here. We know the period is what? 2, right? So boom, 2. Here's boom what? Here's what? 2 pi over who? What is half of 2 pi over 3? What's half of 2/3 pi? You sure? What is the middle? If the distance is 2/3, what's the middle? Okay, so if my whole length is 2/3, what is my middle? 1, right? 1/3, right? Okay, are y'all okay with that? You got to use your brain for it to work. Okay? If I'm at 2/3, what's half of 2/3, guys? 1/3, right? If I take 2/3, split it in half, I got 1/3, right? Okay. Here you go. Here. Pi over who? 3. Now, ready? Where does sine start? Where does sine start at? Because this is sine, not cosine, right? Where does sine start? Go back and look at your 3 that we graphed the other day. These are the parent functions, right? Where does the sine start? Over? No, it didn't start over. It starts where? It started at where? Go get your sine, parent sine function. Come on. If you don't use it now, don't ask to use it tomorrow. Do you understand? Come on. Look at your parent function. You got to know what it's, where it starts, what it looks like, and all that, guys. I mean, come on, look. I can do this. Let's see if I can grab another. Here. That's the easy stuff? No, here's the easy stuff. If you don't like the graph, make your what? Own, right? If the graph is not conducive to make it easier for you, who says you can't do it as you said? So here, let's look. Oh my gosh, here it is. Look, this is what you ought to have out on your paper, right? Where does it start at? 0, 0. Where does it end at? At the end of its period, where does it end at? Yeah, but on an output, 0. Do you understand? Cosine was up at the amplitude, right? Sines are at who? 0. You with me on that? Any question? So, look. So I know it ought to start where? There, and then where? And ought to cross where? Correct? That's the middle point, right? Okay. What is half of a third? What's half of a third? What? Oh my gosh. Love you right now. It's awesome. Pi over who? And so that would be 2 pi over 6, which would be what? 1/3. So this would be what? 3 pi over 6? Right? 1 pi, 2 pi, 1 pi over 6, 2 pi over 6. Would it? I'm asking. 2. This 2 pi over 6 is what? What's 2 over 6? 1/3. What comes after 2 pi over 6? 3 pi over what? 6. Which would be what? Pi over what? 2. Because that would be what, and then 4 pi over 6 is who? 2/3. You with me? Okay, watch it. This is crazy. Watch this. So I got a 0, 0, 0. What's my amplitude? Done. Did I have to evaluate? Why? Why did I have to evaluate? Didn't have to evaluate. Say. Huh? Come on. Work with it. Tell me what your frustrations are. Tell me what you see. Tell me what you're not seeing. Is everybody good on my zeros as outwards? The beginning and the what? End. Y'all with me? Yes or no? Chandler, you okay with that? What's the middle of it? The middle is, if I have 2/3, the middle is 1/3, right? So that's also got to be a 0, right? Here's why. Let me show you. It's got to have that shape, right? And a sine wave, the original period is 2 pi, right? So the halfway point would be what? Pi, correct? So I know in the middle of it, I'm going to have a dot, right? The slap middle of it. Now, how can I go where you go, Paul Rouse, I don't know if I can get to here. I don't know if I can get to pi over 3. You got the period, did you not? It was 2/3, right? Take 2/3 on your calculator in parentheses and divide it by 2 and tell me what you get. Make sure 2/3 is in parentheses and divide it by 2. Stay present. What is it? 1/3. Okay, do you see how we got that? So we're going to take the period and we're automatically going to half it, right? Yes? I needed it for cosine. I still need it for sine, right? Okay. Look where I put my dot. So I said, okay, pi over 3, boom, dot. I have 0, 0, and 0, right? Beginning, middle, and what? End. Yes or no? Now, guys, I did. I put that over the wrong thing, didn't I? Thank you, Jay. I just saw that. Right there. Thank you. Okay. Take 1/3. Take 1/3 and divide it by 2. Tell me what you get. 1/6. So in between pi over 3 and 0 ought to be pi over who? 6. Any questions on that? Anybody? Y'all okay with that? If you try to graph it on the graph that is on the worksheet, you're not going to do it because it's in pi over what? 4s, right? It's definitely by pi, and I'm going to tell you, your brain, you can get these numbers, but you can be like, it's a lot easier to make your scale be what it needs to be, right? Y'all with me? Okay, now. If I'm at 0 here and I'm at 0 there, and I'm at the halfway point, that has to be my amplitude, right? Are y'all with me on that? Raise your hand if you're seeing that. Raise your hand if you're not seeing that. Okay. This is the sine wave, right? Stop, drop, look, and listen. Those y'all that said I'm not seeing it. This is my sine wave. This is the parent function, right? Everybody understand that? If I go the whole length, that's 2 pi. Half of that is what? Pi. So I got a dot in the middle, right? Y'all understand that? I got 3 zeros, do I not? 0, 0, middle, and who? End, right? Y'all with me? Okay, now, what is halfway between pi and 0 here? Pi over who? Y'all see that? Smack dab between the middle and the beginning ought to be my amplitude, my crest, my maximum, right? Halfway between my middle and my end ought to be my trough or my minimum, which would be my negative amplitude, right? Do y'all see that? I don't think the thing of what's getting you right now is I think it's more fractions than anything. Yes or no? Yeah? Okay, so y'all want to do something real quick? If you'll use this, it will make your life a lot easier. You ready to do something? Let's do something. Because you're going to have to be flexible enough to know your fractions. You remember me saying about, I don't know, a couple of days ago, end of last week, learn your what? Fractions? I told you, if you learn your fractions, everything will become much easier, right? Okay, I'm not lying to you. I promise you that. So let's create a fraction. Let's see. You may have to do 1/12, but I very seriously doubt it. So let's do this. Huh? Let's do 1/6. 2/6. 3/6. 4/6. 5/6. And then what? 6/06, right? Now, sixes can also be in terms of what other denominator? 3. With me? Okay. We do that 0, right? Okay. This, if I'm looking at 1/3, right? This is my 1/3 line, right? 2/6 is the same as what? 1/3. 4/6 is the same as what? 6/06 is the same as what? 3 over what? 3 over 3, which is what? 1, right? Okay? Yes? Do you see what's in between thirds? What are they? 6s, right? Yes? Okay? So, if you look at this right here, from the very beginning to here, was my period, right? Where's the middle? 2/6 or what? 1/3, right? Because if I go 1, 2, 3, 4, if I go over 2 or back 2, I still get it who? 1/3. Do y'all understand that? Okay. Now, how many separations are between 1/3 and 0? Between here and 0, how many? 1, 1/6. How about from here to here? 1. For a sine wave to get to that type, it has to be at the top of that, right? And at the bottom. Okay? Let's do another. Quarters you ought to be okay on, right? We can do quarters and eighths and stuff. We can do this stuff right here. All right? Now, let's see. Okay, I want to go back to here because we haven't really graphed it, have we? So, right? If my lines would have went through the dots, it would look like that, correct? Okay. Where's my next sign on that sheet? What is it? What is my amplitude? What is my period? It's 2 pi over 3. What was my period on my previous? What if they done to you right here? Pi over what? 4. Is that going to really make sense? Now, you know what you could do? Change this to pi over what? 3. Change the pi to what? 2 pi over what? 3, right? You could do that. Or you could, right? How many zeros will I have, guys? Where are they located at? Beginning, middle, and what? End. Right? Halfway between the beginning and the middle ought to be, if it's not flipped, ought to be a what? We're asking these two questions, guys. Halfway between the beginning and the middle ought to be my what? Amplitude, positive amplitude, right? Halfway between my middle and my end ought to be my, okay? This is what I need for you to do. You've got the front and back of this, right? You need to go back and you need to sit down and you need to really see what you know. Like, I was wanting you to do that last night, but let's just be honest. Did you? No. You've got to get comfortable. You've got to wrap your head around it. You've got to do a little bit of thinking. All right? So, that's what I want you to do. You'll have a quiz tomorrow. What will it be over? Okay, hold up. It'll be over coterminal in degrees and what? Gradients. We've done that, right? And then I may pull out some questions of please find amplitude RD, period. Fair enough? We won't graph yet. Y'all not there.